All right, I think we're recording here. So this is the first part of the Resonance Systems Lab, and I'm so sorry you can't just sit here and play with these simulations, but you can't. So run this simulation. That's the simulation right here. So try different periods. Let's try 1.6. Now I'll give you a clue. The resonant frequency of this little oscillator here is 2 seconds, right? So you can guess what frequency it wants to be driven at, but let's mess with this, right? So let's put 1.6 in there. And let's run this. Little button right off the side of your screen there. And you can see it oscillating away. Initially, you get this sort of, it's almost like a beat frequency. The envelope has its own distinct frequency. But it will eventually kind of settle down on some sort of amplitude here. That's just because of this startup here. It'll settle down to some amplitude. Now, the driving period is 1.6 and the resonant period is 2, so we're pretty far away here, and so it's not going to, really doesn't like this. This is a small amplitude. And notice that we are, let's see, I guess we are a fast oscillator, so. No, we're a slow oscillator compared to this driver, right? So we're almost 180 degrees out of phase too. All right, so I'm going to stop this. I'm going to reset it. They say try 1.8. Well, 1.8 should get better results. This one seemed to top out about less than 0.5 meters. 1.8 is a little closer to its resonant frequency, so I'm expecting a little bigger amplitude. And sure enough, it's not disappointing us here, right? Ooh. And it'll do the same thing. So 1.8 is a little closer. We'll get a little bigger bump like that. It'll settle down to some amplitude that's, I think, about between 0.5 and 1. Okay. Anyway, I'm going to stop that because this is probably really exciting for you. Now let's try 2. This is its resonant frequency, right? And this is, the resonance curve you've already seen. It's going to just basically ramp right up to its maximum amplitude here. That's pretty big, right? I mean, if there weren't any damping, by the way, it would just keep getting bigger and bigger. It would never stop. We're giving it energy, and it would just never be able to lose it. But that only exists really in math class. So the amplitude here is about 3. Just remember that with a damping factor of 0.2, whatever that is, right? Okay. This thing peaks out at about 3. Now, dutifully, we need to try 2.2 and 2.4, right? And as you might imagine, 2.2 is just a little too fast for it. So we're getting, we'll get a bump. It's pretty close to it, but it's not quite right. So it's going to go up, it'll go down. It'll get that sort of same weird undulating envelope. It'll woo, and eventually it'll settle down to something. Notice now we're kind of in phase with the driver because we're actually a fast oscillator compared to the driver. All right, stop, reset. Dutifully, we said we'd try 2.4. So there's 2.4. And again, this is far enough away from the period, the resonant period, which is 2 seconds. Right, we don't really expect a huge amplitude here. Interestingly, though, it looks like it's settling down to something a little bigger than 1.6 did, right? Anyway, you can see that, right? So let's stop, let's reset. Okay, so the rest of the lab says, okay, the system has a resonant period of 2 seconds. And that bold stuff over there, just answer those questions, right? What is the resonant relationship? You know what that is, right? But, there it is, right? Which driving period achieves the highest amplitude? Well, you saw it, right? Sorry about that. Okay, the damping frictional force is the proportional velocity for a driving period of 2 seconds. Change the damping. What is the relationship between the damping and the ultimate amplitude of the system as well? This is fairly straightforward to you, right? Remember, damping is something that takes away energy, right? So if we get rid of damping, so let's make the damping. Actually, let's go back to the resonant frequency, so 2. All right, let's hit run. Remember, this thing basically, I think it leveled off a little more than 3 meters of amplitude. And that's with a damping factor of 0.2. Let's just see this again on how long it takes to reach that. It's still going up, right? The rate at which it's increasing, though, is we have a possible negative second derivative. Eventually you'll become so nerdy that you'll laugh at that. All right, so there it is, right? So it's peaking out a little more than 3, so let's stop, reset. Okay, and let's change the damping to 0.1. Well, with less friction force, what do you think is going to happen to that amplitude? This is less frictional force. I think the amplitude is going to be bigger. What do you think? Ooh, it's already bigger. Yeah, look at that. I think we can definitely say that this is a bigger amplitude. Whoa, what's it going to even level off at? We just okay, so stop. Obviously, if I try, 0.2 is what it was before. Now we put it to 0.1. What if I put 0.3? Obviously, you must have something better to do. But if you really don't know what it's going to do, keep watching. It's going to level off. But it's got more damping, right? More damping than the original one we tried. The original one was leveled off at 3. When we did it at 0.1, we leveled off at God knows what. It was more than 5. And when I do 0.3, it seems to be leveling off sooner, and it seems to level off at about 2. Okay? So anyway, I think we've answered that first question, that first part. So I'm going to, I guess, pause this.